Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the live chat, and then we are going to start the today's live session. And one of the important thing which I would like to share with all of you, tomorrow, that is being Tuesday 21st of June, I won't have any class. So we will resume our class from day after tomorrow onwards. I repeat, we will not have any live class tomorrow, but from day after tomorrow onwards we will be continuing the same pattern. Agreed? Perfect, no? So the student who must have joined my video or the lecture first time, let me briefly discuss about the agenda behind this video and the videos which had already come, probably 9 number of videos earlier. We are going to cover almost all important topics of the engineering mathematics which are been related to your GATE syllabus. The topic which we had already started is been probability. Within the probability, the 4 different topics are been there. Among them, the first is been permutation and combination. The second is been the word problem related to the probability. The third is been stats, and the fourth is been random variable and random process. The part of permutation and combination is already been covered in last 10 number of videos. So the student who had been new for my lecture, they should also watch the remaining videos. The 10 number of videos are been already there. And from last video onwards, we had started the basic concepts of the probability, or I should say the basic word problem based on the concept of probability. As my videos are supposed to come on Gate Academy Global, that means my mode of communication is going to be in English. The timing is going to be 7:30 p.m. at daily basis. 7:30 to 8:30 we are going to spend together. Agreed? So let me focus over the important point which we were discussing in the last class. In last class, we were discussing about the important terminologies which are being associated with the probability. The first important terminology was a random experiment, which we had already seen. A random experiment. The second important terminology was fair or unbiased experiment. Unbiased experiment. In the same sequence, we had also discussed about the sample space. Then we talked about the favorable events. Favorable events. We talked about the probability for the occurrence of a certain favorable event P of E. May I know what does it mean by the random experiment? The name itself has been quite self-explanatory. The experiment whose outcome has not been predictable, or whose outcome has been random in nature. A die is rolled, the outcome could be anything in between 1 to 6. If a coin is being tossed, the outcome could have been anything in between head and tail. It's been a random experiment, fair experiment. So any kind of the experiment you had been conducting has to be fair in nature. You should not give any bias to any kind of event. Otherwise, the result what we receive, like rolling a dice, finding 1, probability as 1 by 6, rolling a die, finding outcome as even as 3 by 6, definitely those answers are not going to be correct if the type of experiment is being an unfair or biased experiment. Sample space, which collects all of the possible events from a random experiment. If I say what would be the collection of sample space, or what would be the sample space? So the sample space is going to be the collection of all possible data. What I'm saying, the collection of the all possible data. And if we'll talk about the collection of all possible data, if we roll a die, obviously the collection of all possible data would be 1, 2, 3, 4, 5, 6. Similarly, if we toss a coin, obviously the collection could be head and tail. Similarly, we had also discussed about the favorite event. What does it mean by the favorite event? It could be anything. Like, you might be conducting a random experiment and your favorable event could have been finding a even number, finding a odd number, finding a prime number, finding 1 number to be greater than 5, number to be lesser than 2. So depending on the different problem, definitely the favorable events are supposed to change. If we'll talk about the P of E, the P of E indicates the probability for the occurrence of a certain event E, P of E. And how the P of E is being defined? The P of E is being defined as the number of elements or the number of terms which are being associated with your favorable event divided by the total number of events which are being associated with your sample space, N of S. N of S. Anyways, we will not take a long class in today's class because we are going to have a session as well. So what we are going to do, we are going to take few number of questions straight away. With the help of those questions, we will try to learn few more important concepts, and from day after tomorrow onwards, we will go ahead with few more important terminologies which we will be using again and again within the probability. So let me do one thing. Let me straight away hop into the important questions. Important questions. So here comes the question. Here comes the first question. This question has been experienced in metallurgy. In year of 2016, the problem was phrased by ISC Bangalore. What the problem states? A coin is tossed 3 times. It is known that out of 3 tosses, 1 is head. The probability of other 2 tosses also being head is. I would like to know how many of us would be able to get the correct most answer. But while giving the answer, you should read each and individual terminologies, each and individual words which are been associated with this problem, because this problem is bit trickier problem. What the problem states? A coin is tossed 3 times. Let's say a coin is being tossed 3 times. May I know how many different possibilities we are going to have? 8 different possibilities we are going to have. In first trial, the possible outcome could be head or tail. In second trial, head and tail. In third trial, head and tail. So as 3 independent outcomes are being connected together, we are going to have total 8 number of branches, total 8 number of outcomes. It is known that out of 3 tosses, 1 is head. The probability of other 2 tosses being also head is also head is. May I know what would be its possibility? What would be its possibility? First of all, it is been a type of one important data is already been supplied. 1 head is already been occurred. So I would request to each one of you try to read this problem carefully, and then only you should answer this problem well. Let me give you 1 minute. Within 1 minute, read the problem carefully and tell me what could have been the best most answer. My dear students, this has been a problem of conditional probability. Conditional probability. It's been a problem of conditional probability. What does it mean by the conditional probability? Apart from the problem, if few more additional conditions are also being supplied with the problem, obviously the problem becomes a type of conditional probability. Although the 3 coins are being tossed together, the possible outcome could have been anything in between head, head, tail, tail, head, tail, the 8 possibilities we could have had. But in this problem, this has been clearly said, this sample space contains only and only those elements which had at least 1 head. Which had at least 1 head. What does that mean of it? If you'll try to make a sample space, 2 coins are being tossed 3 times. The possible outcomes would be 0, 0, 0, or I can say 0, 0, 0, and then comes 0, 0, 1, then comes 0, 1, 0, then comes 0, 1, 1, and here comes 1, 0, 0, then 8 possibilities. So many of the students would think, sir, this had been our sample space. No, my dear friend. As per the additional condition which had been supplied along with this problem, it had made sure that the outcome had the outcome which contains at least 1 head. May I know whether this outcome would be the part of sample space with this condition or with this supplications? No, sir. This, yes, sir. This, yes, sir. This, yes, sir. Yes, yes, yes. Why? I had taken the remaining 7 number of events. Why I had left the first event? Because first event does not supply or does not comply the condition which had been supplied along with this problem. Did you understand what I am saying? Did you understand what I am saying? So if I say the probability for the occurrence of my favorable event, where the rest of the tosses should also have head, put together all of the faces are being had. How many total events that had been? Only one event we had. Out of how many number of events? 7 number of events. So may I know what would be the best most answer? 1 divided by 7 is going to be the best most answer. Should I repeat this problem once again? The problem states a coin is tossed 3 times. One thing has been quite sure. If a fair coin must have been tossed 3 times, there would be the 8 different events within the sample space, which starts from tell, goes till head, head. But along with this problem, one further information or the condition is also been supplied. That if coin is being tossed, it had been made sure that it contains at least one head. Then what is been the probability that the remaining tosses are also been leading head? At very beginning what I did, I have listed down all of the events if a coin has been tossed 3 times. So obviously the 8 possibilities we had. But among them, the one possibility has been completely ruled out if you comply with this additional condition which had been supplied along with this problem. So you had just been left out with the 7 different events. So if we'll talk about the number of event in your sample space, rather having 8, it had been reduced to 7. And if we'll talk about the number of favorable event, 1 is already been had. We want that rather 2 is to be also had. What does that mean of it? Out of 7 number of event, only 1 event satisfies this requirement. So the result has been 1 by 7 exactly. The result has been 1 by 7 exactly. Yes. Result is been 1 divided by 7 exactly. So I don't find any of the student would have any kind of doubt till this moment of point. I would request to each one of you, just give the feedback whether this problem has been clearly understood or not. If you not understand this problem thoroughly, definitely I can reconceptualize this problem into the different way as well. Write it down somewhere. It has been a problem of conditional probability, because along with the problem, the additional condition is also being supplied. So in future, when we will be detailing important terms which are being involved with the probability, I would also be discussing about the conditional probability, the probability where the additional conditions are already been given. Additional conditions are already been given. Now what I am going to do, now I am going to rephrase this problem into the different way. A coin is tossed 3 times. It is known that out of 3 tosses, 1 is a head. So rather having 2 had been had, I had taken 1 has been had. Yeah. 2 are head. Then probability of the other 1 toss also being head. Other 1 toss also being head. Again, it's been a conditional probability, because once a coin is being tossed, there had been 8 different possibilities, but out of that 8 different possibility, it had been made sure that in different events, at least there should be the 2 heads. Then what's been the probability that the last trial or the remaining trial also contains a head? May I know what would be? What would be its best most answer? What would be its best most answer? Can you explain once again, Midun? Just try to understand in this way. In first question, what had been asked? A coin has been tossed. May I know how many total different number of events you are going to have? 8, which starts from tell, goes to tell, head, and comes till head, head. They had been asking that the outcome had made sure that it contains at least 1 head. What does that mean of it? Apart from this event, which contains all of the tell, all of the events carries at least 1 head. It carries 1 head, 1 head, 2 head, 1 head, 2 head, 2 head, and 3 head. So obviously, if we'll comply with this requirement, obviously this has to be ruled out. And as per the problem, whatever the toss has been taken place, it had been made sure that the outcome had at least 1 head. So your sample space would be reduced from 8 to 7. And in this 7 number of events, or from this 7 number of items, you are going to select your favorable items. What are that? That had been only and only head, head. Out of 7 number of outcome, the one outcome is been my favorable event. So the event or the possibility is going to be 1 divided by 7. 1 divided by 7. Yes. Subhangi had given certain answer. Let me check it out whether it's been correct or not. As per the Subhangi, the answer is been 1 by 4. Check it out. It had been made sure The sample space contains those events only which contains at least two heads. So this has been ruled out, this has been ruled out, this has been ruled out. You had been left out with this, ruled out, left out with this, this and this. How many total events are being left out within your sample space which complies your additional information or the condition which had been given? So it had been 4. What are they? They had been THT, they had been THH. Then here comes HTH, HTH and HHT. HHT, triple H. 1, 2, 3, 4, 5. Let me check it out whether the counts are being correct or not. Yes. So this has been the first one, second one, third one and fourth one. This is to be ruled out. This is to be ruled out. Yes. Yeah. This one. Again, we had been looking for my favorable event, and the event is to get all outcome as heads. So obviously out of 4 number of events, only one event is been my favorable event. So if we'll talk about the possibility for the occurrence of my favorable event, it's been 1 out of 4. So 1 upon 4 is been the answer. 1 upon 4 is been the answer. Agreed, no? See, this problem could have been phrased in the different way as well, where the problem is not been a problem of conditional probability. That could have been the simple most form of the problem. A coin is tossed 3 times. What has been the probability that all of the outcomes are being head? No additional information is being supplied. That means my outcome contains all of the possibilities, which starts from tell, goes to tell, head and ends up to the head. In that case, total 8 number of element, total 8 number of items you are going to have within your sample space. In that case, the size of the sample space, the number of elements within the sample space are going to be precisely 8. And out of 8 number of elements, only and only one element is going to be your favorable event. In that case, the probability for the occurrence of all outcomes to be head must have been 1 out of 8. The probability must have been 1 divided by fate. Probability must have been 1 divided by fate. So that is what I am saying. That is been the beauty of the probability. You could have squeezed the problem into the any different dimension. And I would request to each one of you, if you have been preparing for GATE or any of the competitive examination sincerely, you try to squeeze the same problem into the different dimension. You need not to do n number of questions. If you had sit with one question, try to take its all dimensions, because all dimensions are going to teach the different as well as amusing concept, and that is what we have done it with the same question. The starting 2 questions were the questions of the conditional probability. If the problem is being completely rephrased, the 3 coins are being tossed together, what has been the possibility that all of the events or all of the outcomes are being head? This has been 1 event out of 8. The answer must have been 1 divided by fate. 1 divided by fate. I would like to ask from each one of you, the student who had been live in my lecture, if the concept or the conclusion is being clear, just write clear somewhere and then we will move forward. So I would say the 3 different questions are being deduced from the same problem. The first has been the father question itself, where a coin has been tossed 3 times and it had been observed that the outcome contains at least head. The second question has been a coin has been tossed 3 times and it had been made sure that at least 2 heads were there. And the third question has been the simple most problem. The coin has been tossed 3 times. What's been the probability that all of the outcomes has been head? All of the outcomes are being head. Agreed? So what I'm saying, in future when we would be discussing about the conditional probability, you should be able to recall this concept once again. When the problem comes under the conditional probability and when the problem is being unconditional completely. Unconditional completely. Let me take the next question. Already we have brought few number of questions, because in today's class I am not going into the theoretical part of the probability that we will do day after tomorrow. I am going to take few number of questions which are being the basic word problem of the probability. Let me take this problem. This has been the second question of the day. What the problem states: a fair coin is tossed till a head appears for first time. The probability that a number of required tosses is odd is. required tosses are to be odd is. This problem contains a different flavor, and I had seen this problem has been a pet problem which do come repeatedly in the different branch. I can say one thing, if you'll take the major streams which includes electrical, electronics, mechanical, civil, where the number of people are being huge, each year this kind of the question is used to be experienced by either of the branch. Such a important question has been. This has not been a traditional way of solving the problem, but this kind of the problem has been a pet question in GATE examination. That is why I thought to take this problem in today's class. A fair coin is tossed till a head appears for first time. The probability that a number of required tosses is being odd is. Anyways, whenever you read the question, you try to figure it out, the practical aspects of the problem itself. Or I would say in daily basis or in daily activities, you must be able to relate this problem. The problem states, when I win the game, let's take a coin is being tossed. In first toss itself, if the head had appeared, I had won the toss because this has been my first trial and the first trial has been the odd trial. If I could not get one in first trial, definitely I had to toss a coin once again. And if I got the head in second trial, I had been a loser. I had been a loser. Because whenever my first head takes place in odd trial, then only I am going to win. So what we had to do? We had to lose this trial. We had to lose this trial, and then I will go into the third trial. And if in third trial, if I get head, definitely I had been the winner. And this process goes on until and unless I do not get head in first trial. I do not get head in the first trial. Agreed? So may I know in what are the different ways I could have win? In first trial itself, I could have got head, or in third trial I could have got head, or in fifth trial I could have got head. I could have got head. In fifth trial I could have got head. Is that part clear? And this process goes on. And this process goes on. So let me focus over the first outcome first. My dear friend, what has been the possibility that you are going to toss a coin and the outcome has been head? Obviously it's been half, because the two number of total outcome we had within my sample space, that has been head comma tail. So out of head comma tail, head has been my favorable event that had been 1 in count. So obviously it's been 1 by 2. 1 by 2. May you know what has been the possibility you will be getting head in your third trial? My dear friend, first of all, the turn of third trial is supposed to come only and only if you would have lost in first trial, you would have lost in second trial, and now you had been trying for the third trial. May I know what has been the losing probability in first trial? Obviously in first trial you could have received tail. In second trial also you could have received tail, and now it's been the possibility that in third trial you had received head. And that's been the amusing thing. The probability for the occurrence of head and tail is been same, at least in this problem. This has been the possibility that in the first trial itself you have got a head. This has been the possibility in first trial you could have got a tail. In second trial also you could have got a tail, and then in third trial you could have got a head. You could have got a head. And same thing goes on. May I know when the fifth trial is going to appear? The fifth trial is going to appear only and only you must have lost in starting fourth trial. Yes. Although the values are looking very similar, half, but they had been coming. In first trial you could have got tail. Second also you could have got tail. In third and fourth you could have got tail. And here comes the head. Here comes the head. So there are infinite number of terms we are going to add over this series. And one of the best thing regarding this series has been they had been making a GP. They had been making a GP. Agreed or not? Obviously, sir, we are able to agree. We are able to agree on that. We had to add them together because the or sentence is being used, and whenever the or do takes place, the value of probability gets increased. The value of probability gets increased. What has been the first data? The first data has been half. The second data is 1 by 2 raised to the power of 3. The third data is 1 by 2 raised to the power of 5, and you can have total infinite number of terms in this geometric progression. How can I call this progression as a geometric progression? Because you can see in successive terms the ratio remains common. 1 by 2 to the power of 3 divided by 1 by 2 is been 1 by 2 to the power of 2. 1 by 2 to the power of 5 divided by 1 by 2 to the power of 3 remains again 1 by 2 to the power of 2. 1 by 2 to the power of 2. So its addition had a formula, and as we know, S in GP series is equals to of A r to the power of n minus 1 divided by of r minus 1. In this problem, the value of r is being half and the value of n is being tending towards infinity. So if you'll feed this data, limit n tends to infinity, A we will write later on half to the power of n minus of 1 half minus of 1. Agree? See what had been happening. What does it mean by half to the power of n? The half is been multiplied by itself n number of times. But if n is been ranging towards infinity, what would happen? Half getting multiplied with half, which would become 1 by 4. Half is been 0.5, 1 by 4 is 0.125. And as the value of half is keep multiplies, what would happen? This value would be deducedly, it would be continuously reducing, and end of the day this becomes 0. And that is why you should have a clear-cut idea for GP series. The sum of starting nth term is been written as A r to the power of n minus 1 divided by r minus 1. Yes, but if magnitude of r is being lesser than 1 and if the n is been tending towards infinity, what we write? SGP for infinite series is being, this becomes 0. A gets multiplied with a minus of 1. Even this minus of 1 could have taken towards the downside, could have been written as A divided by 1 minus r. But this has been a possible case only and only if their addition converges to a certain finite value. And you can see very well the value of half and the value of r is been 1 by 4, which is been magnitude of r lesser than 1. It would converge to a certain fixed value. So may I know what would be its worth? So I would say the probability is simply gonna be A, that is been 1 by 2 divided by of A divided by 1 minus of r, and 1 minus of r is been 1 by 4. So towards numerator side we are going to get half, and towards denominator side the 4 is going to get subtracted with 1. The result is going to be 3 divided by 4. Anyways, the intermediate values are going to get multiplied, the extreme values are going to get multiplied. So the result is simply being 4 divided by 6, or I can say 2 divided by 3. So the best most answer which we had been receiving out of this calculation is simply being 2 by 3. It's simply being 2 by 3. I would like to ask from each one of you whether this concept is being clear or whether to be taught once again. In this problem, what they had been talking of, a coin is to be repeatedly tossed until and unless you get head first time, and that too in odd number of trial. So I tried for the first trial. If I have got the head, more than happy. This is been the possibility and my game gets terminated over here. If I take another scenario, now if I wants to win in third trial, obviously I must have been escaped in first as well as the second trial. How it takes place? I could have got the tell in the first trial, I could have got the tell in second trial. Then only I will come down to the third trial. So I have got a tell. What's been its possibility? It's been half. I could have got the tell in second trial. What's been its possibility? It's been half. And then I have got a possibility to do a trial in third. Obviously there also it's been half. There also it's been half. So I had seen many of the times the problem related to the geometric progressions are being asked specifically from the domain of word problem related to the probability. Such an important topic it had been. Let me change the flavor of this problem a bit. Rather, rolling a die, I had been taken a question where rolling a die is being taken. So I am going to change the nature of this problem a bit. Now this has been a problem of rolling a dice. Winning probability. If win for me is being defined as getting 6 in odd trial. In odd trial. May I know what would be the answer over here? Why I had recraft this problem? Because in case of tossing a coin, even the probability for receiving head and tail was same. So even your concepts are not been clear, still probably you may be getting the same answer. But here if your concept is been shaky a bit, definitely you will be leading something else. May I know what would be the best most answer? So here comes. What has been the possibility that you could have win your game in first trial itself? It's been 1/6. What has been the possibility? A die has been rolled and finding its outcome as 6. It's been 1 out of 6. Or for reaching the third trial, you must have escaped in first trial. Obviously, you could have received anything apart from 6. It could have been 1, 2, 3, 4 or 5, anything. So obviously, there had been the 5 possibilities out of 6. And you could have escaped in second trial as well. And that has been 5 divided by of 6. But you could have succeed in third trial. You could have succeed in third trial. Or this has been the win in first trial, this has been win in third trial. Here goes, this has been the win in fifth trial. This has been the win in fifth trial. And here, how many times 5/6 is supposed to come? 5/6 is supposed to come 4 times, and 1/6 is supposed to come only and only 1 times. Again, it is been a GP series which contains infinite number of terms, and once we add them together, we get the probability or possibility for getting outcome as 6 in odd number of trial, which includes 1, 3, 5, so on and so forth. So can I use this formula? S infinity is equals to A divided by F1 minus R. Yes. Only 2 requirement has been predefined. The number of terms or the terminologies which are being involved with the GP must be infinity, and the magnitude of R or the magnitude of the common ratio has to be in between 0 to 1. If I'll talk about the number of terms in this geometric progression, obviously it had been keep ranging towards infinity, because in fifth trial also, if you had not been a winner, you will go for 7th. If in 7th trial also you had not been winner, you will go for 9th. And one of the best thing what had been happening, you do know, as you had been going towards a higher trial, the probability has been keep decreasing. That means it has been more probable that you will be winning here itself. Somewhere here, maybe somewhere here, somewhere here. I would say, what has been the possibility that you will win in the first trial itself has been 1. What has been the possibility that you will win in third trial has been lesser than 1. And similarly, what would be the probability that you will be winning in the fifth trial exactly? It's been again infinite. Put together, if you'll add them together, why I had been adding together? Because if you will win in a first trial, third trial, fifth trial, sixth trial, they all are been my favorable events, because I want to win in odd trial. In odd trial. If somebody would have asked, what has been the possibility that the person is going to win precisely in third trial? That means he has lost in first trial, he has lost in second trial, he has lost in he had win in third trial. So in that case, the possibility must have been p/6 into p/6 into 1/6 into 1/6. नहीं हाँ. Is that part clear to all of us? So let me start feeding the datas. The A has been the first term in geometric progression, that has been 1/6. 1 minus the R has been a common ratio. So obviously you will take the division between these two terms. 1/6 goes off, and the result is going to be 25 divided by of 36. The 1/6 remains as it is. Towards denominator side, we are going to take 36 minus of 25 divided by of 36. Divided by of 36. Anyways, 36 is going to get divided with 6. So towards the numerator side, we are going to get 6. And 36 gets subtracted with the 25. The result which we are going to get, it's been 6 divided by 11. 6 divided by 11. So I don't find any of the student would have any kind of doubt, at least at this moment of point. Here comes the next question. Here comes the next question. Anyways, I am not going to take the third question in today's class. Let me take the fourth question, because the third question requires a little bit detailed analysis, which I am not going to do in today's class. Let me remind once again, tomorrow I won't have any class. Straight away I am going to have a class day after tomorrow. Day after tomorrow. I won't have any class tomorrow. Read the problem carefully and tell me what would be the best most answer. Read the problem carefully and tell me what would be the best most answer. two dice are rolled simultaneously, the probability of the sum of the digits on the top of the faces of two dices are to be even. Anyways, if the two dices are being rolled together, may I know what are the different number of events we are going to have within your sample space? Obviously 36, which includes 1 6, sorry 1 1 1 1, then goes 1 2, then goes till 1 6, goes to 2 1, 2 2, 2 6, 3 1 3 2, 3 6, 4 1 4 2 4 6, and the last event is going to be 6 comma 6. How many total number of events we had over this sample space? Obviously sir, this has been n of s, number of elements within your sample space is been 36. May I know out of this 36 number of events which are been the event which favors my requirement? My requirement is been their addition must be even in nature or even in sum. Obviously once you add them together, the result is been even. If you add them together, the result is been odd. Put together, one thing has been quite sure. If both of the numbers are been even, their sum would be even. If both of the numbers are been odd, their sum would be even. If one is been even and one is been odd, the result would be odd. So in first row, how many total events we had out of 6 which satisfy my requirement? Obviously it's been 1 1, and then comes 3 1, then comes 5 1. Yes, so one thing is been quite sure, 3 are been the favorable event, 3 are been the favorable event. In totality 18 are been the favorable event, and once we'll divide them together, the result which we are been receiving is been 1 divided by f2. Rather having their sum to be even, they must have asked their sum to be odd. Obviously in that case also the remaining is going to be odd, because odd and even are been mutually exclusive events. If the even takes place, it can't be odd. If the odd takes place, it can't be even, if we'll take the reference of natural numbers. So obviously in that case also the answer must have been same. Answer must have been same. And yes, we are going to have the session on main channel. There our agenda would be how to utilize the test series for gate or the preparation of gate. Precisely that is going to take place at 9 PM. So we will meet day after tomorrow, and then also we will be having the span of class 1 hour. Till then, bye bye, take care.